Hi, my name is Michał Michalczuk. I'm a senior software engineer in Spartys, but today I'm moderator for this webinar. The stage belongs to Maciej Przepióra. This is our first day of Java Webinar Week, one of the 5th days. And hi, as I mentioned, my name is Michał Michalczuk. I'm a senior software engineer. Guys, can you mute it down? Thank you. Okay. So as I mentioned, the stage belongs to Maciek today. Maciek is writing computer programs since he was a kid. At least that's what he claims. So when he finished his mixed studies, molecular biology and computer science, nice. IT was his natural career choice. He's been developing web applications in Java and JavaScript for over 10 years for various companies around the world. And for over a year, he is working in Spartys, developing Jira for Atlassian. And beside that, you might meet Maciek as a speaker at Devoxx.PL, JDD or Confitura conferences. And today, mostly Maciek will talk about microservices and API gateways and server-side UI. So, oh my, the last mile of microservices. And if you have any questions to Maciek, please write them down on chat, on Facebook or YouTube, wherever you're watching that. We'll pick them up and we'll have a short Q&A session in the end of our event. So probably about 15-20 minutes in the end will be dedicated Q&A session, so be there. Watch for unexpected slides on Maciek's presentation. I won't tell you why, but watch for them. And Maciek, the stage is yours, and we see each other just after the presentation at the Q&A. Thank you.
Sure. Thank you very much for introducing. So yeah, today I want to talk about microservices and actually about the last mile of microservices, about the front end in microservices. And this area actually has some interesting and non-obvious choices that you can make when you're architecting microservices-based systems. So I'd like to introduce you to those non-obvious choices today. The first part of my presentation is setting the stage. So I'll be talking a bit about microservices. Why are we compelled to use microservices architecture? What are the benefits and trade-offs that we need to make? Then I will be talking about most common approaches to UI in microservices systems. And then I will have something special for you, something that is a non-obvious choice and I think worth considering, at least when you're a Java developer. So yeah, let's jump into it. So why do people choose microservices? Why microservices are so popular today? So one obvious choice or one obvious answer to this question is that it's fashion-driven development. You've probably heard the term. Microservices are fashionable nowadays, so everyone is doing them. And if you're not doing them, then you're lagging behind. And of course, that's not a valid reason to choose, or not entirely valid reason to choose microservices. We'll get back to that, to this notion, but there are better reasons to choose microservices. So why microservices? Seriously. The first and I think most important factor affecting people choosing microservices is that they have some kind of experiences with big ball of mud anti-pattern, which means a system that has been organically developed over time and has grown into a big ball of mud, right? So it sticks together, it does the job done, but it's mud, right? So it's very pliable, but on the other hand, there's no structure to it. And working with it is just getting dirty, right? So that's one thing. Systems that are like big balls of mud are too big to be understood by one developer. Onboarding new developers to such systems takes forever. Few key employees in the company, usually it's few or maybe even one key employee, know most of the stuff. And well, the bus factor, the amount of people that you can afford to lose from the project is very low. So if someone decides to go on a sabbatical year or is hit by a bus, right? Then you're basically screwed with your project. And there's not much that you can do about it in a big ball of mud. So microservices try to answer this kind of problem. What else? Everyday development in such a big system is very slow because, well, it's usually a big system, a monolith. So you need to spin it up. You need to give it some time to warm. And then you can start your debugging session, for example, and it takes forever before you can actually hit the breakpoint that you want to debug, and so on and so forth. So if you make a change, then you need to redeploy it to your local instance of application server, or maybe upload it to some remote application server to your development environment. And it takes so much time, right? And then before you actually get something done that reaches production, it takes weeks or months. So you don't see effects of your work. And as a side note, microservices let you do what Amazon did in 2011 if you implement it properly. They deployed the change into production every almost 12 seconds. In 2011, that was 9 years ago. So like their lead time is much, much better thanks to microservices. Then you might hit into scaling issues if you have a monolith kind of system that is all packaged into one deployment unit that you just drop on the application server. Then you might run into scaling issues because different parts of your system might require different resources to scale. For example, when you're producing a PDF file, which is, I think, quite a common function in most of web software, right? I know it's a PDF report from your accounting system. This process of producing a PDF file, this is a memory hog. It requires lots of memory because, well, that's how PDFs are made. Doesn't matter. Then you want to sign this PDF because let's say you want to send an invoice that is a signed PDF. And signing PDFs doesn't require lots of memory, but it requires a lot of computing power. So basically, if you have it all in one system, you need to scale on two scales, on the available memory size, and on CPU power. And this is basically very expensive because getting powerful machines that are both beefy with beefy CPU and high amount of RAM, that's expensive. And you don't actually need both of them at one time in your process. So let's talk about scaling. Actually, there are actually 3 dimensions by which you can scale any application, more or less, at least when you're architecting. So the first dimension is scaling by hardware, and that's a very classical way of scaling applications. So you have a front load balancer that distributes requests coming from the clients into different instances. That's, for example, how Jira data center works. So it has a load balancer in front, and this load balancer distributes requests to instances of running application. That's quite simple way of scaling. And the other way of scaling is by partitioning, right? So you can scale your application by assigning specific users to specific instances, and you need to configure load balancer so that it knows that when a user with a name that starts with A comes, he's being served by instance 1, and so on and so forth. And this is another rather obvious way of scaling, but then microservices propose another way of scaling your services or your application. It's scaling by functional decomposition. This is the heart of microservices, in my opinion, at least. So what you do, you're breaking your big monolith application into small applications that do one thing very well, and then you let scale different parts of the system differently. So you can have a PDF generation service scale with RAM memory. We can have PDF signing service scale with CPU power, and that's completely that's completely independent, right? So you can, if you need to generate lots of PDFs, then it doesn't matter if the CPU power is that you require for that is available, because what you care about is memory, and so on and so forth. So yeah, that's what I think is the heart of the microservices. Let's get back to problems with monoliths. Big systems are vast systems and are literally impossible to test end to end. So it's impossible to perform at an end-to-end automated test. Maybe it's possible to do a manual test, but who wants to test manually? And then we're getting back to fashion-driven development. What you usually end up with, a big ball of mud, is also an obsolete tech stack. And is it actually fashion-driven development? Not really. In my opinion, smart developers are rarely interested in tangibles only, in money only. And hiring smart developers is harder and harder. So when candidates hear what technologies are in use, you want them to be excited, right, about what you're using. And with big ball of mud, it's really hard to upgrade your tech stack because you're so much invested into it. With microservices, you can upgrade separate parts of your system independently. So it's easier to keep it up to date. Okay. So yeah, what you want to do is break from monolith, but this might be hard. There are various things that, are trade-offs that you need to make. But the most important thing is that architecture matters. Even though it has very little to do with functional requirements of the system, but it matters because it provides for non-functional requirements, like the qualities of the system, like the scalability, maintainability, extendability, security, and so on and so forth. So one thing that it's really worth to remember when thinking about microservices is that because of Conway's law, microservices are very hard to implement in a traditional settings, because you need to have independent, self-serving teams so that they can develop independent self-serving applications or micro applications, right? Conway's law says that organizations that design systems are constrained to produce designs that are copies of the communication structure in those organizations. So basically, the software reflects the organization that made it, right? So that's why I'm saying that it's really hard to implement microservices in traditional setting, in, let's say, waterfall. So yeah, let's move on. One question that we need to ask ourselves when we're architecting a microservices-based system is, how do clients will reach the system? There are other questions, of course, but this one is the one that I want to focus on today. So one option is we have different clients for our microservices system. We have a web application that is single-page application written in JavaScript. We have iOS app. We have some probably third-party integrations available. So what we can do is we can set a firewall in front of our backend services and just let it sit there so that we don't get attacked. And then we expose everything to the world. And this is probably not a good idea. Fine-grained APIs that we will get with this kind of setup will require clients to make lots of requests to get actual job done. And front-end developers will be like, I need to do 50 requests before I can display a view. WTF, what's wrong with you guys, backend guys, right? Then the other problem with that architecture is that clients, they know too much about internals of the system, of this box backend services. And the problem is that it's difficult to change architecture, change the APIs when everything's exposed to the external world. And you usually end up with something that is distributed monolith, because when you have changes, you need to roll it out in a synchronous manner. And then if you want to have third-party integrations, you need to have a stable API. So this is a no-no, basically. So that's why the API gateway pattern emerged. The API gateway takes care of insulating the backend services from whatever we have in the outside world. And that's basically the sole role of it. And the API gateway has a couple of roles. It needs to route the requests. It provides things like API composition, translation of the protocols, so that you expose HTTPS to the external world, but you don't want to have it inside your system. Then you can do it two ways. You can have one size fits all that expose everything to any kind of clients, or you can have APIs per client type. And then there are things that are called edge functions. Edge functions are things like authentication, authorization, rate limiting, all the non-functional qualities of the system that are visible to the outside world. Yeah, so how to develop a microservices gateway, an API gateway? Well, one thing that you could try do, and what people do, is using microservices chassis, like, Spring Boot with starters, or Micronaut. That's one way of doing it. But what about edge services? Then you need to separate them into an additional layer in your microservices system. And that might be fine because you have separation of concerns. But the thing that you need to consider is that there is an additional network hop with that setup. And this means more latency and more additional complexity. You can embed edge services in the gateway, and that's how it would look like. So you have like API gateway that has its common layer. That's those common services like rate limiting, security, and so on. And then you have API layer. The API layer might be separated into three different parts, like mobile API, web applications API, and third-party APIs, but that's not required. We can blend it into one layer or one box. You can have some things that is called backends for front ends. So you actually separate those you have separate gateways for different kinds of front ends. So you have a separate gateway for mobile clients, separate gateway for single page application client, and separate third-party gateway. That's also a viable option. But in the end, you need to implement this API gateway. And there are two ways of dealing with that. One is off-the-shelf product or service, cloud service. For example, Amazon has a AWS API gateway. Other clouds also provide this kind of functionality, but the problem with at least AWS API gateway when I was looking into it was that it didn't support API composition, and obviously you had to be on AWS. So you're just basically vendor locking in. So yeah, you can use a gateway product. That's the other option, not a service, but a product. And there is, for example, Kong, that uses Lua scripting language for plugins. The problem with Kong is that Community Edition, which is open and free, it doesn't provide much functionality, so it's basically crippleware. There are other products like Traffic, written in Go, or Tyke. Or you can roll your own API gateway, and there are things like, for example, for Java developers, we've got Netflix Zool or Spring Cloud Gateway. That's the other option. And then, if you think about it, you can actually try to invert the control. That's what, for example, GraphQL is all about. Instead of trying to straight-jacket clients into APIs that are available, remember this slide when we had this different clients using different API gateways and different APIs. So instead of doing that, what you can actually do is you can choose clients. What are the data that the backend will return? And that's graph-based APIs. So it gives clients control over what data is returned. There's only one API to support diverse clients. And it might be oversimplifying, but just to understand the idea, it might be that you treat as the system as a database, and the front end is executing queries on top of it, right? And in Java world, there's Netflix OSS implementation of GraphQL. Then there's Apollo for Node.js. There are other options, but what I'm trying to talk about, what I want to talk about today, is inverting control even further. So instead of letting the front end decide or query the backend, we're gonna embed the client in the gateway, and we're gonna use the client to render views only. And okay. The important notion here is that it only works for web applications. I don't think it would work for mobile applications because I don't know of a single technology for mobile that would work that way, but it might work very well for web applications. And let's talk about layers in basically any web application. In any modern web application, we will get things like JavaScript client, the communication layer, which is basically HTTPS. Well, we were talking about API gateways. So there's an API gateway, and then there's backend services. So in case of client-side UI, all first three layers are basically dealt with front-end code, right? So there is a single-page application that performs HTTP AJAX requests. It accesses API gateway. And then this API gateway takes care of forwarding requests to the backend services, right? But if we invert the control, as I said before, and we reach to server-side UI, we can embed the UI in the gateway, right? And we can have the rest of the front end automated for us. And that's how, well, one technology that I know and I want to talk about. That's how it works, and that's why I think it's very nice for microservices as well. Today's secret keyword is Vaadin. So what is Vaadin? Vaadin is a UI framework for Java that lets you develop server-side UIs. It means that the state of your application is actually kept on the server side. In this case, in case of microservices, on the gateway, and it takes care of collecting the data from backend services, but it insulates the front end that is being run in the web browser from backend. So how does it work? Let me show you a short demo. So let's switch to code. So we've got IntelliJ. So that's how a sample web application in Vaadin would look like. So yeah, I'm gonna show. Sorry. Yeah. So I'm writing a web application in Vaadin, and I'm gonna stop what's running right now. Let's say that I'm gonna have a button. So I have a component that is called button. Let's call it my button. I will create a new button. I want it to have some kind of a text on top of it. So
Maciek, I'm sorry I have to interrupt you, but we still see only the presentation, not the code.
Sorry about that. That's good that you... it should be better now. Okay, sorry about that. Yeah, so let's get back to Vaadin. So right now I'm using Vaadin 14. There is a simple Maven archetype that you can use for generate a new web application. Everything is nicely explained on Vaadin.com. So I'm going to create Vaadin application that displays a button. So I'm going to use a button class. And I want to have some caption on it. So I'm going to add a caption like this, click me. And if you ever did any kind of UI development, you know that usually the most straightforward way of adding some kind of functionality or some kind of any life to your components is by using listeners. So this button listener actually supports click listener. So I can add click listener. And I'm going to use Lambda for that. Why not? So there's another class notification that allows showing notifications. So I'm just going to add a notification, display a notification that says hello. And let's run it. So I'm going to use Jetty. As you can see, this is all generated by the Maven archetype. So I don't need to do anything I don't need to set up any infrastructure. I just use Jetty that is already included and just run it on top. And yeah, now I can access it in my browser. So let's go to the browser. We'll call host 8080. Yep. And I forgot one thing. What I need to do is I need to add this button to my view, right? So I need to add my button like this, and maybe build the application. And you can see that Jetty picked up the changes and is reloading. Yep, restart completed. Let's reload it. Oh. No, that's not what I wanted. Oh, maybe I need to restart Jetty to that. Yeah. So yeah, how it works. This is all Java code that is actually being executed on the server side. So it all lives on the server. And the state of the application is kept in HTTP session. And Vaadin takes care of automating all the requests and rendering the state of the application in the browser. So if I go to network and reload the application, you can see that there are some initial requests. There are some resources being loaded. And then when I click on the button, there's a request being made, the server side. And then I get a notification here. So yeah, a request is being sent. And in this request, I'm going to have it as a separate window like this. So in this request, we're sending a remote procedure call, basically. So we tell the server side that the user clicked on a button in the UI. So there is an event that is being automatically transferred by the framework to the server side. And then on the server side, we pick up this event and we have a listener that is attached, and this listener is being executed. So a notification has to be shown. And that's what in the response for the request that we just made. Here. So in the response, we can see that there are some changes being introduced to the UI. And one of them is that we need to have a notification shown with value hello. It's I'm gonna find it. Yeah, it's here. Right. So this is the answer that tells the front-end engine that a notification should be shown. So what is nice about this setup is that you can develop a web application with Java only. And there is a vast component library that you can use for your applications. Buttons, tables, one of the most advanced grids on the market, and it's all free, open source. There are charting components. There is a spreadsheet component available. So any kind of application, there are maps components, and you combine them using Java code and executing this code on the server side. And one nice thing about it is that you can add breakpoints. And now I need to stop it and start debugging with Jetty. So I'm gonna add Maven run. Like this, apply, okay. And I'm gonna debug it. And once I start debugging it, okay, yep. Yeah, you should be able to see the code better now. So I can add a breakpoint here. And now when I click the button in the browser, I will actually hit this breakpoint. So let's load the application. Yeah. You see that? Now I can start debugging my UI code in IntelliJ, in Java. That's something that I know. Nice, right? And I think that's very powerful feature of Vaadin, actually, one of the most powerful. The other is that, well, you can build nice looking applications because all the defaults are there for you, and it's stylable. You can use CSS to style it, but let's not dive into details. The actually important thing is that all you need to know is decent Java, and that's it. And you start developing like a front-end pro, right? Okay, so let's stop it. Let's get back to the presentation to finish it up, to wrap it up. So let's close IntelliJ. Let's get back to Keynote. So question is, what should you do? The answer is, as usual, or as with any seasoned consultant answer, it depends. If you choose to use server-side UI for microservices frontend, you get a lot less control on the client side, but you will see increased development speed. Familiar programming model for backend developers. And if you ever did desktop programming or mobile programming with UI components, that's a very familiar model. So it's very easy to get started with it. A final food for thought: if you think that good architecture is expensive, you should try bad architecture. And that's it. Thank you very much. That's all I had for today. And let's dive into questions and answers to the Q&A section of today's webinar.
Thank you very much, Maciek. Maciek, now you can take a short break, take a glass of water. Let me just check the notes which I've made. I have one. It wasn't a question, but I will made it a question. Maciej wrote that who would even use Vaadin in 2020? And I also wanted to ask about it because I remember Vaadin as that kind of solution from the previous generation of the UI when you tried to use Java or C# and .NET environment on the UI. What are the advantages for using, for example, Vaadin above using, I don't know, any kind of popular JavaScript solution? Besides that, it's Java, and we know Java in the example you mentioned.
Well, that depends on actually kind of the application that you want to develop, I would say. So if you're trying to do something that is a next Facebook or Twitter, I wouldn't recommend looking into Vaadin because it's basically not suited at it. But most of the applications that we develop or people develop, it's, well, maybe not most, but many of those applications are back office applications. Things like tables, forms, and I believe that there is no single faster tool than Vaadin for that. I mean, when you need to develop this kind of back office application was, let's say, Angular, because that's what's popular in this kind of setting, right? Then you need to develop things like backend, so database, that's what always needs to be done. Some services, REST APIs, that's what usually people do. And then secure it. Make sure that you don't have any kinds of cross-site scripting and anything like that. Or maybe not, maybe you're just don't care about it. And then you need to develop an Angular frontend for it. Then you need to test it and so on and so forth. There is no way it's going to be faster than Vaadin. No way, basically. And Vaadin is actually quite nice with scaling as well, because it's not actually that big. If you know how to develop a Vaadin application, it will not take that much memory in the HTTP session. But you need to basically be careful about that's for sure. But it's the same with REST-based APIs. You can't shoot yourself in your foot when you're loading the whole table into the memory, and then you're just filtering it with your Java code in the REST controller, right? So you can shoot yourself both ways.
True. I wanted to ask what you just mentioned, so about the size of the server session. One more question about Vaadin. Have you used it in a commercial project?
Lots of them. I used to work for Vaadin. And we delivered projects written in Vaadin. Actually, there was one, for example, ERP system for dental clinics in the United States, AXPM, and it uses Vaadin. So yeah, there are commercially successful applications that are written in Vaadin out there. I know that lots of I'm sorry. Just to finish, lots of financial institutions in Germany use Vaadin for their back office applications as well. So,
okay. Another question, also about Vaadin. Were the notifications sent by regular response body, and is the support for web server events available?
So the first answer is yes, that is sent by the response to the request that was made when we clicked the button. So what actually happened was that when we clicked the button, an AJAX request was sent by Vaadin engine in the browser, and it sent basically an information. A user clicked a button. This user clicked this button, and by the whole machinery in Vaadin, I don't have the code available readily, but the whole thing about Vaadin is that it automates it. So it lets you connect a Java listener to an event that happens on the browser side. That's how I would sum it up. So yeah. And the other question was,
what about server side events like server push or WebSockets, I believe?
So Yeah, so Vaadin doesn't support server-side events. That's something different from WebSockets, but it actually uses WebSockets by default. So you can very easily do things like background processing and send in notification after some time, after some background processing is done, for example. That's very easy with Vaadin, actually. Much easier than I can imagine with anything else. So, yeah.
Okay, and now I have really a wall of questions about microservices. Wall of text, yeah. Wall of text containing questions about microservices. So let me start with, oh my God. Let me start.
I need to get some light. Okay.
Go on, please. Let me start with that. Question from Bartosz Drozd. Should microservices share common resources? And if so, what is the best way of doing it? Let's say that I have service A and service B, which are doing completely different business logic, completely different stuff. But they're making some calls to external APIs. Should they share some common auth credentials or stuff like that? Or should it be duplicated?
Well, what you basically want with microservices is independency in terms of deployment, but not only in terms of deployment, but also in terms of developing the application. So my take on that would be that you want to avoid sharing anything as much as possible, right? You want to have a team that is basically responsible for one thing and it does it well, and it doesn't depend on anything else. So this is kind of extreme, and it's not always possible, but that's what I would suggest leaning into.
So rather stuff should be duplicated to avoid coupling.
Yeah, you want to avoid coupling between different microservices in your system. I'm disappearing. I'm sorry.
You disappeared, yeah.
Yeah, I know. It's just too dark in my room. I'm gonna get some light in a moment.
Go on, please. Go on, please. I'll take a quick look at our question. Okay. Question from Kaniol or Kaniol, Kylie, or Kaini, or however to pronounce that. Since Spring Boot allows going for either, do you think there's any advantage of going reactive over servlet, or the other way around?
Oh, that's a tough one to answer because everything you know about Java threads is going probably to change with Project Loom. I personally think that reactive is a convoluted pattern that tries to solve a problem that shouldn't even exist. But yeah, I know it's very popular nowadays because it lets you scale, right? What is happening with threads in Java sometime soon, no one knows when, is that Java is going to get green threads again. And this means that Java Virtual Machine will have its own thread scheduler, and it will let you run millions of threads. It will let you do things like structured structured concurrency or structured multi-threading. And there is one very nice article about what's going to happen available on Project Loom's webpage. Maybe we could add it as a comment to the video after the webinar. I have it somewhere in my favorites, and basically I would stick to servlets because this is going to be changed a lot with the future version of Java. And reactive has its own problems. I mean, it's really hard to write the code because it's really hard to debug such code, right? Because you're jumping between the executor's code and your own code, and you can easily end up with a situation that you don't want to end up in. So yeah, that's it.
We know that.
So it's a temporary solution. I would say that that's a temporary solution, but it's not going to be needed soon.
I have a small question about the explanation of microservices. If you could comment it with a few short sentences. By microservice, do you mean a small application that does small job, or it is typical service in code which also do the job, or maybe both? If you could explain a little.
So yeah, microservices actually are a couple of things. Because we can talk about microservices at deployment, and that's what most people understand when talking about microservices. They mean the deployment model. So we have different servers, different applications that are completely separate. But that's not the only model to implement microservices. I mean, in Java world, you can easily implement microservices architecture with OSGI. I wouldn't recommend it, but it is possible. So you still have everything in one machine, in one, I don't know, VM or in one container, but you can still have microservices there that are separated by interfaces that you introduce on the boundaries of the system and so on and so forth. So it's both ways, actually.
But in general, it's more over a small program, but it can be really small. I have
usually it is implemented as separate nodes in a network and having them communicate by HTTP.
Oh, this is such a good segue to the next question by Marcin Kwiatkowski. Hi, Marcin. Microservices should talk internally with each other. What is the most preferred way for you to let them communicate? Which protocol, service bus, etc. would you use?
Again, this depends on many things, like what is the size of the communication, right? So if it's a simple kind of a communication, when you don't care about the size of the messages or latency, REST API with JSON or anything like that. If not, if you want to have things like event streaming or anything like that, or you want to have event-based communication, then it all depends on a specific context. So you actually need to think about it as and that's actually the role of architect or architects, to think about it and figure out the best way. So there is no simple answer here. I'm sorry.
And sticking to the microservices and maybe some battle story. Do you have maybe some battle story to share where microservice approach helped you, or maybe when it bites you, you know?
I was bitten by such an approach once. What we ended up was a distributed monolith. That's the worst hell that you can end up with. So it means that every kind of or every part of the system knows about every other part of the system. Again, we're getting back to this Conway's law. The system that the organization will develop will reflect the communication between the teams in the organization. And if there is one ruling architect that rules everything, that's what you probably will end up with.
And could you give us some example of using microservices at Spartans? The question is about Spartans, but I believe it's actually about Jira.
Well, Jira Cloud. That's what's happening, I believe. Jira Cloud is transitioning into microservices. That's what I think. That's what I should tell here. I'm not working with microservices at Spartans because I'm working on the server offering. So not too much to share about it here.
Not today, but stay with us on Java Webinar Week. We'll have Alec and Alek is one of the architects in Jira Cloud, the same organization where I'm also working, and he'll tell you a lot about it. As I remember, Alek is on Friday.
Yeah,
I believe.
I suppose so.
I believe it's Friday. Okay. Oh, another good question about microservices and communication between them. What kind of solutions do you recommend to reduce network latency between microservices? So here we have we've narrowed down kind of communication to some network protocols.
Yeah, so the most important thing that you need to do is you need to be able to measure it, and that's what you should start with. So distributed tracing, there are ready-made solutions for that, but you need to have numbers. You need to have statistics. You need to basically gather that data. That's the first step. And then one of the most obvious things is that you usually expose your services by HTTPS, but you don't need it internally. So turning off HTTPS in the internal communication might be something that you want to consider. There are some reasons not to do it. For example, if you want to use certificates for attesting the identity of nodes inside your system, if you want to be on the paranoid side of security, then you won't do that. But HTTPS, lifting HTTPS is the first thing that comes to my mind, right? And then, well, measuring, maybe thinking through the granularity of your APIs inside the system. That's something that you should look into. Maybe caches. That's a very broad discussion, actually.
True. I wanted to ask more about the security part that you just mentioned. There is one more question from Nation. I hope I pronounced it correctly. How do we secure service-to-service communication with some bearer token, or how they authorize to each other? What are the popular patterns?
Well, again, that depends. You can use things like certificate-based authorization and authentication. You can use tokens, and that's quite popular. So basically, especially if you want to have this audit log trace, you can have the API gateway add some kind of a header on in your HTTP requests that are routed down the stream, so that you can have this trace. And yeah, there are different options here, and I don't have one to recommend, because again, it all depends on a particular situation, right? On particular application. But there are some options to think of.
Marcin Kwiatkowski is making a pressure about solutions to reduce network latency. He wrote that please list at least 2 non-REST ways that you have used. I am wondering what was okay for your projects. I went through monolith microservice migration too. Let's say a potential payload are not small. Microservices have its own databases. JSON sent by REST are just way too big. So stuff like gRPC or P2P or probably protobuf are on the plate. Do you have maybe some recommendation or some thoughts about it?
Well, I can have only general recommendations. A general recommendation is to observe and base it all on data and experiment, because there are too many workflows, too many knobs and variables that you can change, that it's really hard to recommend one thing. shared database is also an option. You need to consider it. You need to think through it. You need to figure out what are the pros and cons, and that's always some kind of a trade-off that you need to make, right? So I really wouldn't like to recommend a particular approach because it all depends on the context, and basically you can shoot yourself in your foot in every possible way.
True. I think that it's also good to save those questions. For example, to Alec, I can tell you that, for example, in Jira Cloud, for part of features, we are using protobuf as a format of data. I'm not so sure are we using anywhere a gRPC, to be honest, but as I mentioned, Alec would be good person to ask about it. Let me just add, I think, one more question about the microservices and how to split them. What do you think about the idea of extracting a common authentication functionality in separate module and then use it as a dependency between microservices? I think that a similar question already appeared, but if you could take this one.
Yeah, that's one of the possible options, but then you need to have a separate team that would take care of it, and this creates the dependency. So if that's always what happens when you're trying to separate something. It makes sense to split the system into cohesive elements, but then you end up with dependency. So you need to trade it off, right? But yeah, that's actually quite a common option, to have a separate library or dependency and use it in all the services.
But of course, it should have a owner, a guardian, or however you call it.
Yeah, it needs to have an owner. The code needs to have an owner that makes sense.
Two small questions. I think that they're quite related. So you've talked about Vaadin today. What kind of technology, of a front-end technology, do we use in Spartes, in Atlassian for front-end? Is it Vaadin?
No, actually no. Most
I can take this one also.
Yeah, sure.
I can take
server Jira. Sorry. Go on.
Okay, I can take this one. I can speak for the cloud part. It's mostly React on the modern part of the code base, but also in the places where the dragons sleep, there are JSPA pages. There is Skate.js, of course. There is jQuery, and there is Backbone, Marionette. Name it. Everything.
Yeah, the full zoo. In servers, in Jira Server or Jira DC, all parts of the code, they use velocity templates and jQuery most of the time. Most modern parts are React also. So yeah. But we don't use Vaadin for Jira, unfortunately.
I think that I have one last question for today, Maciej.
Sure.
One more time about sorry. This is a fresh question. Damn it. Do you think it's possible to be cloud provider agnostic as for today? Are we infrastructure as a code tools such as Terraform? Are they able to decouple from your cloud provider, or you're always tightly coupled with the cloud provider?
Well, I think Alec would be better to answer this question. So let's keep it for him. My personal opinion that nowadays it's not possible, but he can expand on this. Alec will probably expand on this in his talk. So
True.
My short answer is no, it's not possible.
Oh, by the way, I see that someone wrote that gRPC does utilize protocol buffers internally. Yeah, true. Sorry, I wanted to say P2P. Okay, Maciek?
Well, thank you very much, and please remember, architecture matters. That's basically what I wanted you to get from this talk. Architecture matters. If you think that good architecture is expensive, you should try bad architecture, and you'll see. That's it. Thank you.
That's a good wise words and a good summary. Thank you very much for the discussion. For sure, if you have registered for the webinar, we'll send you a link. Also, I believe with what you, Maciek, just mentioned today during the Q&A session. And since it's Java Webinar Week, see you tomorrow at 8 p.m. We'll have Paweł Gruszczyński with his presentation about performance improvement story. Thank you very much and see you tomorrow. Thank you very much, Maciek, and thank you for watching. Bye.
Goodbye.